you mind if I just touch a little further on, when we were talking about packaging, what are some examples of packaging? I mean, are we talking like kitchen, like food containers, or are we talking like, what are some examples, I guess?
So I'll take this one. So we produce the specific polymer that then we can take and be extruded into a thin film, and you can wrap food with your plastic film or whatever. And the beauty of these is they're produced biologically, so they're relatively low carbon production. They're not made from petrochemicals, and a lot of these, if you make the right ones, are biodegradable. So you don't have that forever plastic that ends up in the ocean and garbage island in the Pacific. It'll biodegrade some of them within a year, others within 2 years in the natural environment.
Wow.
So you don't have microplastic issues. You don't have the long-term plastics. It can be very beneficial.
You touched on some work with pharmaceuticals. Can you give us some real life examples of that as well?
So there are. I'll start. There are a couple things we're doing. One, we're doing wastewater work. So pharmaceuticals are a big problem in wastewater. Our current wastewater treatment plants don't treat these. So you take your pharmaceutical, most of it doesn't get absorbed depending on the drug, and you excrete it, it goes into the lakes and rivers, and then we take the water and we drink that again. So the idea is to work with the wastewater cultures, which some of them they are level 2, and use different processes to degrade or destroy these pharmaceuticals or PFAS, those forever chemicals, and destroy them before we reintroduce them back into the lake system and then drink them again.
A lot of people don't think about that, right? I mean, people are taking their medicine, we all go about, we need that, but then we're not thinking how that then can come back in.
Yeah.